right, I think we're live everywhere. Appreciate y'all joining. Back live again for another coding challenge. Doing it in real time. Another easy Leetcode problem, quote unquote easy, called valid anagram. Yeah, valid anagram. So, gonna be trying to run through this one quickly tonight. And y'all are learning with me. Y'all with me, and we're gonna figure it out, or we're not gonna figure it out. But we're gonna get through it some kind of way. So I'm gonna give it a few more seconds, and then yeah, I'm gonna get started. Appreciate everybody joining. All right, I think I'm gonna get started. So tonight we're doing another Leetcode problem, easy problem called valid anagram. So given two strings S and T, return true if T is an anagram of S and false otherwise. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So basically, these two words are anagrams if they have the same number of letters, different kinds of letters. So if you rearrange the letters in the words, they would equal each other if you ordered them correctly. So an example here is S is this and T is this, and basically they have the same number of A's. They have one G, they have two A's, they have one N, they have one R, and they have one M. And then if you look at rat and car, it's not an anagram because there's no T in car, there's no C in rat. So you get false for this example. The constraints are S and T will always have at least one character in them, and they're guaranteed to be less than 5 times 10 to the 4th power. And then S and T consist of lower English letters. I'm not gonna worry about the follow-up here, but yeah. So this is supposed to be an easy problem, but I'm sure when you're first getting started, you'll have trouble with this. I know I did. So yeah, let's try to run through this. So here's what the code they give you to start with, but I'm just gonna take a step back and think about how you could solve this. So, if you're in an interview setting or if you're just practicing these, what I always like to do is think through the problem first, talk through the problem first, make sure that I, verify all my assumptions, that I understand the problem, and then try to talk through a solution. How would I solve this in my mind or with pencil and paper manually, and then try to apply that solution to code, like finding an algorithm or data structure that I could use to solve the problem based on how I'm thinking about it. So when I think about this problem, what makes an anagram is basically the number of letters, the number of type of letters needs to equal, as well as the number of letters needs to equal. So these strings need to be the same size, 1, and the amount of each type of letter in the string needs to be equal to each other. So it needs to be the same amount of A's, same amount of R's, same amount of G's, same amount of N's, and same amount of M's, like in this true example right here. So when I think about it in that case, I need to compare both of the strings. I need to compare, first of all, their length, and I need to compare each type of letter, the count of each type of letter, and make sure they're equal. And so one way I can think to do this is if we reordered these letters, if we sorted or reordered these letters in alphabetical order, then both of these strings would be equal to each other. They would both spell, they'd both be AA. I hope I don't mess up the order of the alphabet, but AAGMNR. And so both of these would be equal in that case. But that would, so you could sort these strings and say is S equal to T if you sorted these. But the sorting operation is important to know that that is big O log n time to sort, which is not as good. It's not as good as linear time. Well, it's actually in big O of n time to sort because you have to go through every string as well in this process. So it's not as good as linear time, which linear time would just be going through these one by one, because you'd have to go through these one by one and you'd have to do basically like the sorting operation as well. So the other solution I'm thinking of, usually when you can't do a solution fast enough with just your algorithm, then you can use space to trade off time to get a faster time. So what I can do here, thinking about how should I count the number of characters. So I could go through one string and simply count the number of each type of character that I see. So I see 2 A's, I can say I got 2 A's. I see 1 N, I can say I have 2 N's. How would you do that? And one way to do that is to use a map. You can use a map that uses every character as a key of the map, and then uses the value of each character being the count of the number of times you saw the element. So I could loop through this and say put A in the map, put N in the map. Okay, I already have A, so put 2 for A in the map because I have 2 A's. And then put G in the map as 1, put R in the map as 1, put A, increment A in the map as 3 since I've seen 3 A's, and put M in the map as 1. And then when I can come through this string and I can look at the map and I can decrement the map, or I can create a whole separate map for this one and just do the same thing. And then I can make sure that both the maps, all the keys and values are basically the same. Or I can use one map, decrement the second map, and if every map has 0 value in it, like decrement the values as I see the different characters, then I know I have an anagram. And so that's the explanation on how to solve this problem. Now I'm going to jump into the code since I've pretty much over-explained. I mean, it may be hard to understand, but hopefully it'll be easy to understand when I actually jump into the code here. So let's jump into it without further ado. And hopefully I don't screw this up in front of y'all, but I'm going to try. So the first thing I said when I was thinking through the solution is that these strings basically need to equal each other in length. If they don't equal each other in length, there's no way it's an anagram by definition. When I rearrange the letters, there's no way that each letter can be used the same amount of times. So the first thing I can probably check is just simply say if string dot length is not equal to the S string dot length is not equal to T string dot length, I can just say no, this is not an anagram and just return false. So this is anagram respects false, true or false. So named like a Boolean as well to kind of warrant that, or you can derive that from that. And so what's the next thing I need to do? So I talked about making a map. So I can create a map, and in JavaScript, you can use the map key, create a map, and then I can loop through my string. So something you have to kind of know is basic operation. You have to have command of the language when you're doing problems like this and understand how to loop through strings, arrays. This is how you can loop through a string. And matter of fact, I don't even know if I need an iterator here. I probably could just loop through like character of S like this. I don't think I need an iterator to loop through that. So, and basically what I'm going to say, if my map has the character already, then I'm going to update that character's value. Matter of fact, I'm going to do it the other way just for better explanation. If my map does not have the character, then I need to set the map to 1. I'm basically adding this character to the map to say I've seen this character one time. And then if the character is in the map, so the opposite of this, then I need to increment the map value to the next one, like +1 + 1, 2 + 1. So I basically need to get the map value back out and then increment it +1. So here I set it to 1 because it's the first, because it's not in the map yet. So I set it to 1. And in here, I take the map's value that was already in it and increment it because I've seen the same character over again. So like in the case of, A, I'm going to be like incrementing it 2 more times to make the map value for A, for the key A, equal to 3. So let's come back here. So at this point, I should have a map full for string S. I should have a map of keys for every letter, and then each value for those keys is the frequency in which the character occurred in the string S. And that's basically what I've done so far with this. And for the second string, so character of T, I need to loop through T now. And for T, I need to check the same map, because what I plan to do here is decrement the map. And instead of adding to the map like I did here, I want to decrement the map and try to get the map's value down to 0, because if the string is an anagram, then for every letter I put into the map, I should take a letter away, because the string should have the same frequency of letters in it as T should have the same frequency of letters as string S. So let's say if the map has this character, then I'm going to set that to map char -1. I'm just going to basically do the opposite of what I did here. Else, if it's not in the map, if a character in T is not in the map, then that means this is not an anagram. Like, there shouldn't be anything that isn't in the map. Because if it's an anagram, then every letter is going to be in the map at some point. So, yeah, so it should be in the map. If it's not, then I should just say false. So now I should have, after this point, I should have a map that has been, everything's, I should put a colon here. Everything should be subtracted from where I put in the values on the first loop. The second loop for the second string should subtract the frequency of characters. So I should have a map. If it's an anagram, I should have a map of all the characters as keys, and the value should all be 0. If all the values are not 0, then that means I don't have an anagram. If I went negative, or if they're positive, that means I had a frequency imbalance in the letters. So what I should do is, I gotta remember how to do this. I think for key of map keys, I think this is how I get the keys out of the map. I might screw up here, but that's what we're doing this for, to like, try to make mistakes and learn from them as I'm going. So I think I can get the keys out like this. I can loop through, and basically I want to check if the map get key, if this does not equal 0, because all these should be 0, then I want to return false. I just want to break out. If I never return false from here, then I want to return true. We have an anagram. If all these do equal to 0, I'll never return false, and I'll get down to this case where these are true. So this looks right to me. Let's walk through it again. What I was trying to do, I checked the string lengths first. The strings need to be equal in size, or it can't be an anagram because the frequency of the characters won't match up. So I'll return false in that case. Here, I'll populate the map. If I haven't seen it in the map yet, I put it in the map as 1, that character of the string S. If I have seen it, I take what's in the map and add 1 to it. Here for T, I check the map. If it has the character, I decrement it. Whatever the current value is in the map, I decrement it by 1. If the character is not in the map, then we don't have an anagram, so I know to just break out here without doing any more work. And in here, I check the keys in my map, and basically I'm looping through the map, and then I check each key, and if one of the keys does not equal 0 as its value, then I return false, because every key should be, because I've added all here, and I've taken away all the values here. So I should end up with keys with all 0 values if I have a valid anagram. So this looks right to me. And what I like to do is, sometimes if you're in an interview setting, you won't be able to run the code and you have to walk through it yourself. So I like to do this as an example. I like to use an example and basically write down all my variables in a comment here and keep track of like what the current values are. So I have a map, I have S, and I have T, and I have a map. And do I have anything else to keep track of? No, not really. Oh yeah, see, I see somebody said, I've seen it also done with both strings are sorted alphabetically and then compared for equality as a return statement. So I've seen that too, that actually is in one of the answers in Leetcode, but it's less performant than this solution because you're sorting the strings, because it takes work to sort the strings. Like sorting the strings is, I think it's log n, big old log n. And then because you have to compare the strings at the end, then it's in big old log n, which is more than linear time. Like here, I'm just going through it linear time, but I'm using more space. I'm using in big old N space. So it's a trade-off for space and speed. I'm doing it faster, but I'm using more space. So I think either solution is good, but in the interview, they might ask you to switch over to one of the other solutions. So I'm glad you mentioned that. But anyway, so I'm running through this S and T. I'm using the example cat, rat, and car, which should give me false. So when I go through this loop with S, does the map have R? No. So I'm going to add in R is 1. And then I'm going to loop through again. Does the map have A? No. So I'm going to add A1. And I'm looping through again. Does the map have T? No. So I'm going to add T1. And then I break out of this and I go into this. For T, for car, does the map have a C? No, the map does not have a C. Return false. So I will return false out of this whole method, which is correct. I should get false. And then I want to do another example like of an anagram, an actual anagram. So tar and rat should be anagram. So if I go rat, I don't have to go through the first time because I already did it. So the first time here is rat, and I've basically created this map. The second time, I'll be going through it tar. So has the map have T? Yes. Subtract T is what the operation is here. Now I should get 0. Does the map have A? I go to the next in the loop. Map have A? Yes. It's going to be 0. Does the map have R? Yes. It's going to be 0. And then I'm going to get down to this. I'm going to go through all my keys. Is there a key in the map that doesn't equal 0? All these keys equal 0. So I'm going to skip this. I'm never going to hit this, and I'm going to return true. And in this case, this should be returned true because these are anagrams. So this looks good. I'm not gonna hold up the video much longer. Leetcode allows you to run this, so I'm gonna run it, and we're gonna see what happens if I have a bug up in here. All right, it looks like for this case, I got what I was looking for, which was true. Leetcode allows you to just throw in the rat and car. It allows you to quickly throw in other test cases and run it. And like I said, in the interview, you may or may not have that option. Rat, car. This should be false. Yep. And let's try one where, let's try like rack, but with like the letters are off or something like that. That should be false too. Yep. So cool. So now I'm gonna submit this to Leetcode. Let's see what happens. And looks like, yeah, I got all the test cases right, because otherwise this would have failed. So like Leetcode runs a bunch of test cases on it. And I got 25% faster than other submissions and 52% less memory usage, which is strange because I assume everybody would be using the map and in the same way. So I'm not sure how I did better than 50%. I guess that does make sense. Yeah, I guess that makes sense. It's like right in the middle. So, and yeah, not really the greatest, but I'm not looking for the greatest. I'm just looking to be right and to be most optimal as far as what an interview would be looking for, most likely. So, but yeah, that's the solution. Thanks for watching. Please, whatever platform you're watching this on, like the video to support me, and follow and share and all that good stuff. Let me know in the comments what you feel like, if you can do this more optimally, or any tips or tricks. And let me know if any videos you want to see next live. And thank you guys. Yeah. See you guys in the next one.